Hi, my name is Muhammed Basheer. I'm the president of the Institute of Concrete Technology, and also I'm the chair of structural engineering in the School of Civil Engineering at the University of Leeds. Thank you very much for asking me to give this inaugural address at the International Conference on Recent Trends in Construction Materials and Structures. The talk is entitled Technology Enhanced Education, Training, Research and Management for the Construction Industry. Outline of my presentation is as follows. I start with an introduction to productivity and environmental challenges in the construction industry. I move then to building productivity and sustainability through technological innovations. Briefly touch upon 4 topics: low carbon concrete routemap, precasting and 3D printing, construction robotics, artificial intelligence and construction informatics, structural health monitoring and whole life management of infrastructure. I then move on to building productivity and sustainability through education and training. And finally, I conclude and give some recommendations. So first, productivity and environmental challenges in the construction industry. Here, on the left-hand side, you can see the productivity gap, average value added by employees per hour worked. And the top bar is the global economy, 37 pounds US dollars per hour. And the bottom one gives $25 per hour. This is according to McKinsey and Company, and the source is from 2017. So if you add that, you can get a productivity gap of $1.63 trillion. And naturally, you can see on the right-hand side, there is a big difference between the construction sector and the other manufacturing sectors when it comes to global productivity. And one of the limitations is that we depend very much on the linear economy. And the linear economy gives, we take resources, we process the resources, we manufacture products, we provide service based on that. And in the end, we will dispose of the waste into the landfills. So there is an increased pollution with this linear economy. And this process repeats and the pollution increases. So the resources become less and less, and the waste becomes more and more. And this is actually a slide taken from Professor Phil Purnell from University of Leeds. So the objective of my talk is to demonstrate how construction productivity and sustainability could be improved, how to introduce a range of research and innovation in construction materials and technologies which could improve construction productivity and carbon footprint, how to share some of the ideas in education and training to help improve the quality of workforce and thereby the quality of infrastructure projects. And the first topic is low carbon concrete roadmap to achieve the productivity and sustainability through technological innovation. And this slide is from the UK Green Building Council. And you can see the vertical line indicates the 2021 situation. And if you look at that, the carbon footprint coming from the embodied carbon is much low or lower compared to the operational carbon. And that is the case with the infrastructure buildings, whether you take domestic or non-domestic buildings. So to achieve carbon neutrality by 2050, we need to actually look at all these factors contributing to the carbon agenda. And one of the ways of achieving that is to depend on the circular economy. The benefits are the circular economy could reduce waste, drive greater resource productivity, deliver a more competitive economy, positioned to better address emerging resource security or scarcity issues in the future, and to help to reduce the environmental impact of our production and consumption. So you can actually see that there are benefits for going for circular economy compared to the linear economy. Another thing is looking at this particular slide. This is from Dr. Pete Winslow from Expedition Engineering. You see that if you go for refurbishment of an existing civil engineering asset, you have a huge decrease or carbon dioxide saving compared to any other approaches used for carbon footprint or saving carbon footprint. And in the case of low carbon concrete roadmap, which is actually being developed by the Institution of Civil Engineers, and there is a consultation document available. To achieve the net zero carbon by 2050, there are 3 strategies proposed. One is to reduce the amount of concrete and rebar used, and the second is to reduce the carbon intensity of concrete and rebar, and third is to sequester or offset the residual carbon. Looking through your program for this conference, there are papers at this conference dealing with some of these strategic areas. Now, instead of going through the details of these low carbon technologies, I just wanted to touch upon 3 other aspects. The first one is the precasting and 3D printing. This is the Flexi-Arch, which can be used for small to medium span bridges. So as you can see, the central diagram, there is a flat pack system which is brought to the site. It's lifted, put in place, bolted in shape, and then the full construction is finished. So the bridge can be theoretically constructed in a day, and bridges up to a span of 18 meters was constructed. This is actually now marketed by Macquarie Precast Concrete Engineering, and the work was developed by Professor Adrian Long in Queen's University, Belfast. So it is highly cost-effective and durable, instrumented bridges to facilitate performance monitoring in surveys. The precasting is actually used in India as well. You can see 2 examples: precast house in Uttar Pradesh in India, as well as affordable houses in Kerala using prefab construction practice. So what are the facilitating factors for prefabs? High strength and high performance concrete, advances in admixture technologies, advances in fiber reinforced concrete, advances in pre-stressed concrete, advances in structural connections, better skilled construction workforce, introduction of a whole life cost and life cycle analysis, and better awareness of or concern for sustainability. All these are actually facilitating the use of precast constructions. Now, another aspect is the 3D printing or the additive manufacturing. As you can see from this graph, there is an exponential growth in this technology. And it is one of the most attractive concrete technology options. And due to the advances in material technologies and the use of building information models, construction robotics, artificial intelligence, and construction informatics, buildings can be constructed using 3D printing. And it's an example of a 3D printed building in Dubai, which was constructed in 2019. So comparison between traditional concrete manufacturing procedure and 3D printing is given in this slide. You can see there is the free air from formwork, less labor needed, saving in construction time, better working environment, less construction waste, reducing the risk of construction, and reducing the cost of construction. All these are actually the advantages for going for 3D printing. Now, I mentioned about construction robotics, artificial intelligence, and construction informatics. They, in addition to helping with 3D printing, they can be used for different other applications. For example, for structural demolition, bricklaying, assembling prefabricated components like the prefab construction, welding arms, construction of road pavements, unlocking of design possibilities, and aerial surveys. The market drivers are high level of construction and growth expansion activities. The second one is unsafe environment injuring labor force, and uncertainties such as COVID-19 pandemic, which prevents us from working on site. So the advancement in technology, robotics technologies are widely used to achieve greater efficiency in the performance of construction tasks and to improve working conditions in the construction phase. Another example is the use of virtual sieve for characterization of sand and gravel used in concrete. So you can see in this case, the grading is obtained digitally, and that can be used for deciding how much of bitumen in the case of asphalt concrete and cementitious material in the case of cementitious concrete can be used. So the advantages are better understanding of raw materials while they are in conveyor belt, reduction in energy demand, and increased parking density, and also reduction in cement consumption. Of course, we get actually an improvement in quality control as well. Another application of virtual reality is the assessment of constructions on site as well. So in this case, you can see the virtual reality is used for understanding the performance of a bridge abutment. And this type of information is useful for maintenance management. Talking about maintenance management, structural health monitoring is actually another aspect. And as you can see in this diagram, the blue line shows this situation where at the time of construction or the completion of the construction, the required level of performance is obtained. And during the service life, that performance is not actually decreasing below the minimum acceptable level. In the case of the red line, you can see that the performance depreciates or decreases very fast, and then there is obviously the catastrophic failure of that structure. But most structures actually perform as indicated in the green line. There is a reduction in performance, but before the minimum level of performance is reached, we can actually carry out intermittent repair and maintenance. How do you get this information about the performance? That is where the structural health monitoring system and non-destructive testing will be useful. So as an example, here there is a bridge in China, it's the Hanjie Bridge, where sensors were embedded in a monitoring station located at the service center. This is at the middle of the nearly 36-kilometer long bridge. So different types of sensors can be embedded in the concrete, and using those sensors, information about the concrete can be obtained. There are fiber optic sensors as well as selective resistivity sensors. Some of them can be used for environmental characterization, some of them for chemical characterization. All these can be used in combination for getting information about the performance. And the data can be obtained from the office instead of going to the site and collecting the data on a regular basis. Once we get the data, we can look at the performance and see whether the predicted performance matches with the expected performance of the bridge. And if there is a decline in performance, obviously preventive measures can be put in place. Now, let me actually touch upon education and training. This is where I introduce the Institute of Concrete Technology. The mission of the Institute is to promote concrete technology as a recognized engineering discipline and consolidate the professional status of practicing concrete technologies worldwide. And to achieve this mission, we have certain vision as well. The vision statement is to be a leading international professional institution which will create, advance, and disseminate the science and technology of concrete and the processes for making concrete in both local and global contexts through national and international partnerships and activities. It will provide education pathways to recognize and award different technical and professional qualifications in concrete technology, aligning candidates at appropriate levels of memberships globally, and to ensure a positive global impact of concrete as a construction material for its quality, sustainability, reliability, and economy. So this slide shows the certification scheme we signed up. That's the concrete field testing technician certification. This is jointly carried out in partnership with the American Concrete Institute. So we also have videos for training the technicians, and to different standards, we video record the activities, and these are also used for training purposes. And the main thing is actually provide a qualification system by which the concrete practitioners can get appropriate qualifications at different stages of their career. And associated with each qualification, they can get the membership as well. For example, stage 1 and qualification results in Tech ICT. Stage 2 gives affiliation of the ICT. Stage 3 gives the associate member of the ICT. Stage 4 gives the member of the ICT. So that is the final qualification. And then by application, somebody with the membership of the ICT could go on to become a fellow as well. And in addition to these qualifications, we provide a CPD certification as well. For example, the construction product certification, this is the division of the quality scheme for ready-mix concrete. And we give concrete acceptance and sampling and introduction to site practice CPDs. So there are different ways by which a practicing technician or an engineer can obtain qualification through the Institute of Concrete Technology. And I mentioned about stage 4 qualification. Stage 4 qualification can lead to a university degree as well, with the agreement signed with the University of Leeds. Now, this year is one of the biggest year in the calendar for the ICT. It is the 50th anniversary year. So we have a wonderful program planned, and the technical event is going to take place in the Prince Philip House on the left-hand side. And the dinner is going to be in the Institution of Civil Engineers. You can see magnificent setting of both buildings. And as part of the technical symposium, we will have the Lee Memorial Lecture given by Professor Ravindra there. As you know, he was with the University of Dundee for a long while, and now he works in the University of Birmingham. He is going to talk to us about wide-angle lens view of concrete research from 1970 to 2022. And this is going to be on the 23rd of June, 2022. So please make sure that you book early enough, and details can be obtained on our website, or you can contact our executive officer. Details are on this slide. So as a concluding remark and recommendation, building productivity and sustainability through technologies, we can actually have a social, environmental, and technological solution that is economical for every problem and situation. There are different methodologies available now being introduced by the industry, introduced by research-led technology transfers. And a timely and appropriate decision-making is crucial to this success. Research, education, and training, as well as technology transfer, are key to this success. Professional institutions play an important role in achieving the above, and it is in this context that partnerships are important. So within the UK, we have a Concrete Society and Institution of Concrete Technology working together. And of course, we partnered with other organizations as well. And internationally, an example is the collaboration with the American Concrete Institute and RILEM, and obviously with other organizations as well. And by these international partnerships, we can address industries, government agencies, and academic institutions, their requirements. We can provide CPD certificates, module certificates, diploma, degrees, and research and innovation support as well. So by doing this, we will be able to achieve productivity as well as sustainability in the construction sector. So thank you very much for listening to me. And all I want to say is have a fantastic conference in the next 3 days. Thank you very much. Bye-bye.